All right, 9.8 notes, z-scores, page 17. We're going to use z-scores to compare placement in a normal set of data. So a z-score is the number of standard deviations above or below the mean. We use the formula z equals x minus mu over sigma, where x is the data number, mu is the population mean, and sigma is the standard deviation of the population. So, on a statistics test, the class mean was 63 and standard deviation was 7. And for the biology test, the mean was 23 and had a standard deviation of 3.9. We're going to label both of these pictures. So this is going to be the stats one, this is going to be the bio one. So statistics, it had a mean of 63, the standard deviation is 7, so we're going to add 7 and then subtract 7. For biology, the mean was 23, and then we're going to be adding 3.9 and subtracting 3.9. So notice totally different scores, but it's following the normal curve, where you have some that score above the mean, some that score below the mean for both classes. So part B says a student received a 73 on the statistics test. Find the z-score. So notice that 73 is somewhere between 70 and 77. So it's more than one standard deviation above the mean, but less than 2 standard deviations above the mean. So to find exactly how many standard deviations above, we're going to use the formula for z-scores. So our x value is 73, our mean is 63, with a standard deviation of 7. So remember, you subtract on the top before you divide. So you do the top first. 73 minus 63 would give you 10. And then divide that by 7, you should get 1.43. So this is 1.43 standard deviations above the mean. Part C says that same student received a 27 on the biology test. Find the z-score. So 27. Notice that's more than one standard deviation, but less than 2 standard deviations above the mean. So we're going to find exactly how many standard deviations above. So we use the same formula. So it's z equals, our x value is 27, minus the mean of 23, divided by our standard deviation, 3.9. So you subtract the top and get 4, and then divide that by 3.9. You're going to get 1.03. So that's 1.03 standard deviations above the mean. So between the two tests, which test did the student do better compared to the class? Well, that would be the statistics test because it was more standard deviations above the mean. Part E, another student gets a 75 on the statistics test and a 30 on the biology test. Which test did the student do better as compared to the class? Go ahead and try. Okay, so statistics would be 75 minus 63 divided by 7. You're getting 1.71. And then for biology, 30 minus 23 divided by 3.9, you get 1.79. So they did relatively about the same, but notice this one has a higher z-score, so it means that they did better on the biology test than average. Number 2, the mean speed of vehicles along a stretch of highway is 56 miles per hour with a standard deviation of 4 miles per hour. You measure the speed of 3 cars traveling along the stretch of highway as 54 miles per hour, 70 miles per hour, and 56 miles per hour. So we're supposed to label. So notice this highway is not 65, it's 56 miles per hour for average. And then we're going to be adding a standard deviation of 4 and subtracting a standard deviation of 4. Notice we have 3 values here, so we're going to find 3 different z-scores. So starting with 54, notice 54 is below the mean. So it's 54 minus the mean over the standard deviation. So this will give me a negative 2. Again, it's negative because it's below the mean. Negative 2 divided by 4 would be negative 0.5. For 70 miles per hour, notice that's above the mean, by 1, 2, 3, and then some over here. So 70 minus 56, the mean, over our standard deviation, you should get 3.5. So that's 3.5 standard deviations above the mean. Then our last one is 56 miles per hour. So you do 56 minus the mean over the standard deviation. Notice you're getting 0. It's 0 because it's 0 standard deviations above the mean. So are any of these speeds unusual? Explain your reasoning. You might be tempted to say this is unusual because it's negative. Well, that doesn't make it unusual. It means it's just below average. What's unusual is the 3.5 because it's more than 3 standard deviations from the mean. So this one was much more than most people were driving. Number 3, a highly selective university will only admit students who place at least 2 z-scores above the mean on the ACT that has a mean of 18 and a standard deviation of 6. We're going to label our picture. We have 18, add the 6, subtract the 6. And then it says, what's the minimum score that an applicant must obtain to be admitted to the university? So if they have to place at least 2 z-scores above the mean, well, here's your mean. A z-score is a standard deviation, so 1, 2 z-scores above the mean. They have to do a 30 or higher to be admitted.